Moving on with things that we know about zeros of polynomials. Now we're kind of working this backwards. We are taking the zeros and we are building the polynomial rather than them giving us a polynomial and us finding the zeros. Okay, so we've worked through one example of these. Let's work through a second example. Here they give us the zeros of 1 minus 3i and 2/3. And our job is to find the other zeros, reminding ourselves that imaginary numbers and roots come in pairs, and then find the polynomial with the previous zeros. Now this one gives us a little bit of a hint here. This one tells us that this is a degree 3 problem, which means we should have 3 zeros or 3 factors. Okay, part A, we know that imaginary numbers come in conjugate pairs, so that means I must have 1 plus 3i as a zero as well. Remember that rational zeros, meaning fractions or whole numbers, they don't come in pairs. And we can see this in the examples that we worked at the very first part of this section. So in our first example, we saw that we had a rational one here, and then we saw that we had roots. And notice our roots came in pairs, but our rational one did not. In our second example, notice our i's came in pairs, but our fractions did not. So we've seen this before, you just probably weren't thinking about it at that time. Okay, back to this example now. So I know that I have my 3 zeros. All I need to do then is subtract them from x, and that will give us our polynomial. So I have x minus 1 minus 3i, and x minus 1 plus 3i. Now again, I should technically put parentheses around my zeros here, but I know if I distribute them, I'm going to get the same thing. So that's why I leave off that step. And then I also have x minus 2/3. But we don't typically see fractions in this format here, so sometimes we may need to multiply by a coefficient here to get rid of my fractions. And the easiest coefficient to multiply by is whatever you see in the denominator. So in this problem, I'm going to multiply by a 3. And as long as it's just one constant number, it is okay to multiply by that. So when I do this, I'm going to multiply out my 2 conjugate pairs, and I'm going to take my 3 and I'm going to distribute it through this last parenthesis here. So let me do that distributing first. So that gives me 3 times x, or 3x, and then 3 times negative 2/3, where my 3's cancel out, leaving me with negative 2. Now this is something that we typically see when we work it the opposite way. This is our factors that we see a lot of the times. Okay, now I need to multiply out these 2 imaginary numbers. So distributing my x from my back parenthesis through my front, that gives me x squared minus x minus 3ix. Now distributing through my negative 1, negative x plus 1 plus 3i, and then distributing through my 3i. Gives me a positive 3ix, a minus 3i, and a negative 9i squared. Now, if you were to count the terms that you would have here, you should have 9 terms because that came from 3 terms here times 3 terms there. So that should at least tell you if you have the correct number of terms. Now let's go ahead and let's simplify this. Let's see what happens to all of these i's. My negative 3ix and my positive 3ix, they cancel out. My 3i and my negative 3i, those cancel out. And we know that I squared simplifies to be negative 1. So this is negative 9 times a negative 1, or this gives me a positive 9. So in my first set of parentheses, I have x squared, negative x, and negative x gives me negative 2x, and then 1 plus 9 gives me a plus 10. So notice all of my imaginary numbers canceled out, and that's why we need them to come in pairs, so they do that. And now I need to multiply it by this 3x minus 2. So let me distribute the back pieces through the front again. So I'm going to take this 3x through. X squared times 3x gives me a 3x to the third. Negative 2x times 3x gives me negative 6x squared. and 10 times 3x gives me a 30x. Now distributing my negative 2 through gives me a negative 2x squared, positive 4x minus 20. Combining the like terms there, that gives me 3x to the third. Negative 6 minus 2 gives me a negative 8x squared. And 30 plus 4 gives me a 34x minus my constant term of 20. So this is my final answer. Now, if I were to work this the opposite way and set this equal to 0 and find the zeros, that should give me the solution. That should give me the solution of these three zeros up here. 1 plus 3i, 1 minus 3i, and 2/3. Also notice that this problem told us that we needed a degree 3 equation, so we ended up with that exactly right here, degree 3 equation. That's because we had 3 zeros, 3 factors, hence. So at this time we should be able to build any polynomial as long as it gives us the corresponding zeros.